Okay, so what we do is we'll continue from last week. We were looking at characteristics of research, and it is a process. We've seen it is a process of investigation to find something not known before, something about new knowledge. It has to do, research has to do with new knowledge, with something that's known, not known before. Okay, and it's a systematic, control, empirical, all this scientific way of doing things. So it must originate from a research gap or a research problem. And it follows scientific method, which takes a specific systematic process, plan, and procedure. These are the two main characteristics. You must start with a research gap, research problem, and then it follows scientific method, which is already in your definition. Your class definition is already inside there. And with this definition, then it can be applied to any kind of research, regardless of whether science, technology, humanities, medical, it doesn't matter. Everything must be like this, yeah? And when we say that it starts with the unknown and you come up with a new knowledge, that unknown is called a research problem. So when we talk about research problem, we are not talking about mundane human problem. You must differentiate that. Later, you'll see some examples, and when we, as you go along, we go to problem formulation and so on. We must differentiate between mundane human problem, which is problem that we face every day. We have face traffic jams, we face health problem, we face flooding, we face global warming. All these are human problems, but these are not research problems. You must differentiate that. You must know that there is a differentiation, that these are different. Okay? Although some research starts with mundane problem, which is human being problem, some other research may not start with human being problem. I mean, we don't have any problem. Even if you don't do that research also, it's okay. An example that we have seen last week will be the first two. Okay? About the archaeologists digging sites in Egypt. Okay, they want to know how old this mummy was, when she died, how she died, what did she eat, how many siblings she has. So all these are all not related to any current problem that we face. But still, it is research because they want to try to find something new about the mummies in Egypt, for example. All right. The same thing like number two, they send probes to Mars and so on. It's not solving our problem. Maybe in the future, long time in the future, yes. But no, they're just curious. Is there life on Mars? Okay. Was there a civilization? Are there aliens there? So these are something that curiosity, okay, is basically pushing us to find out. So doing things to find out new knowledge, okay, new knowledge means new data information which is converted into something knowledge that is research. Okay, now we go to number three. What is the problem being solved by a project entitled Enhancing Ion Transfer Using New Aluminum Anti-Corrosion Anodes? Anybody would like to say anything about this? The problem being solved by a project entitled, what's the problem here? What do you think is the what do you think is the problem big? What is the research problem? Honey? Yeah.
Chen here. The research is to solve corrosion issues.
Sorry, who's speaking?
Chen. Hello.
Chen. Okay, Chen.
Hi,
Yes.
morning, Paul. Yeah, the problem is to solve corrosion issue. Example like our fencing, it may be corrode over the times. If you use a superficial anode, you can try to protect the fencing, or you have any structures in the offshore environment. you can also use this technology to protect the 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 structures. So the ultimate goal is to produce how to call it, anti-corrosion for safety issues. Example, for offshore platforms, if if there's no corrosion on the platforms, there's less safety issue about collapsing of the platforms. So it's
Okay.
solving safety issues.
Yeah. Okay. That's. Thank you, Chen. Who else? Hanif, I saw raising hands just now. Hanif. Hanif. No, we can't hear you. Hanif, your microphone is mute. Maybe muted. No. Shuang.
Yes, Professor, I have my personal appealing. I think the problem happened because the gap between the goal and the reality, so there may be some method not many perfect. So we need to improve the method. Yeah, that's what I want to say. So
No. But for this particular number 3, enhancing ion transfer using new aluminum alloy anti-corrosion owners, what is the problem being solved? What is the research problem? What is the research problem? Chen just now says it's about something about corrosion. Solving corrosion of offshore structures, maybe.
Hello? Hello?
Yeah, Hanif. Yeah, Hanif.
Can you hear me? Oh, sorry.
Yeah.
Maybe Shuang can complete his
It's breaking, eh?
breaking.
Not very clear.
Can you hear me now?
Yeah, but you just continue.
Okay. I can say that the problem is already inside the title, which is corrosion of anodes. So simply putting the problem is the corrosion of anodes. So what they are trying to solve is by to enhancing the ion transfer without or to minimize the corrosion of the anodes.
So is the research problem something to do with corrosion? Will solve something corrosion problem? The research problem is corrosion, is it? We can't hear you. Anybody else has any more comments or suggestion? Or Hanif? No. Anybody else want to say something? What is the research problem?
No.
Yeah. Hello. Speaking. Who's speaking?
Prof, can I say something?
Who?
Chen, sorry.
Okay, Chen.
Yes. Traditionally, sacrificial anode is used zinc to we use zinc to produce sacrificial anodes. By understanding from the research title here, they are trying to use aluminiums as a sacrificial anode. So the research problem is to use an alternative materials to replace zinc as a sacrificial anode. That's
Okay.
what I can understand from the title.
All right. Okay, that's closer than what you said earlier. Okay, so we see here, this is an example of mundane problem, okay, and research problem. The mundane problem is being solved by many people. If you say that the problem being solved in this project is corrosion, no. The research problem for this project is not corrosion. All right? Because if that is the research problem, it is not really an unknown because many people have been solving problem about corrosion. Must be deeper. In this case, enhancing ion transfer. That means there is already a way of using ion transfer, but the issue here that people do not know is how to enhance the ion transfer. So that's what we mean by we go between the mundane problem and the research problem. Research problem will be very specific, very down to earth, very fundamental. That is the research problem. So that's why if you go the example in number 1 and number 2 and number 3, okay, even number 3 is not really solving corrosion. The issue that the thing that is being solved by this researcher is not solving corrosion, but his research results and contribution will contribute to anti-corrosion fight, mitigation. Yeah, so anti-corrosion measures later. But he's looking at, nobody is looking into this ion transfer, how to improve the ion transfer. Because this the anodes are actually, the behavior is actually how this soft corrosion is the efficiency of the ion transfer. So how to enhance the ion transfer? That is the research problem being solved. Okay, not the corrosion. I hope you get the point. If you don't understand, you can raise further. Yeah. And finally, number 4, what is the research problem in hydrodynamics of floating plastics? What's the problem being solved? Anybody want to say something?
Can I say something, Prof?
Who?
Hafizuddin.
Hafizuddin, okay.
Maybe in this topic, they are trying to understand more on the hydrodynamics of the floating plastic, not to solve anything, but just to know the nature of the hydrodynamic of that floating plastic, like to learn how the behavior of the water around the floating plastic.
Okay. Anybody else want to say something about this?
Prof. Mio here.
Okay.
I think the problem is on the hydrodynamics nature of the plastic. I mean, the problem is the hydrodynamics.
Right. So, okay, both of you have mentioned correctly, because people tend to say, oh, the problem being solved is the problem being solved is because it's about floating plastic. We have too much floating plastics all over the world, and we are trying to solve that problem. Okay, maybe that come into mind, but no, this research is not about solving floating plastic. So if you talk about that, yeah, you can put in the background of the research. Yes, there are a lot of plastics and in the ocean, and it's damaging the environment and causing a lot of problem to the biodiversity. Turtles eat plastic and and die. So you can talk about that, but that's not the problem being solved by this researcher. This researcher is only looking at how the plastic will behave, the behavior of the plastic when it is floating. Right? So again, what I want you to understand and take home message is there are mundane problems, which is floating plastics. Okay, and there are research problem. Research problem is how the plastic behave in water. So that's the main issue. How plastic behave in water, what is hydrodynamic, and later when the outcome of the research can be used to help solve the mundane problem, which is plastic pollution. Okay, but for this research, no, it's not solving any plastic pollution. The impact or the significance of the research, yes, it can be used later, but the research has nothing to do about plastic pollution. solving the plastic pollution issue. The research problem is actually the behavior, the dynamic of the plastic when it is floating in water. Okay, you get that, eh? Anybody has any question before I go to the next slides? Any comments, any suggestions? Yeah, Abud.
Yeah, Prof. Actually, you mentioned about conjunction, for example, is a mandate problem, which shouldn't be a research problem. Actually,
Sorry. Can you repeat that? I didn't catch it.
I mean, you just mentioned about the conjunction. That is,
Congestion?
yeah, the traffic, and I think when you were mentioned about
Oh, traffic congestion, yeah.
yes. You
During
said
Hari Raya, okay.
yeah, it's not a research problem.
Mhm.
Yeah, actually, my topic is talking about the traffic, but as you said, I'm talking. My research problem is that to develop a smart system to come out with data which is going to solve the conjunction. Means
Mhm.
yeah, means that yeah, we have a problem which is traffic congestion. Everyone is trying to to reduce that, but in my research is I'm trying to get to something new, which is there's a lot of methods. For example, now there's RFD and a lot of this smart system technology. So I'm developing my own system, which is smart system. Also inside that system, I'm coming out with my own logarithms
Mhm.
by trying to solve a daily basis problem which we are facing.
Mhm. Mhm. Okay.
Yeah.
All right. Anybody else has any comments? Anything to add? Okay. No, we go to the next page, yeah. Next page is some examples of research titles and their respective problems. So I should have closed the one on the right. This is from your senior's research proposal. See the title for the first one: Cycling Performance Characterization of Lithium-Ion Polymer Batteries by Varying Ambient Temperature and Humidity. What is the unknown that you are looking for in your research? We ask. And he says, there are no study on the effect of humidity level on the discharge cycle performance of batteries. So the problem being solved is that because the problem is the research gap, okay, or the unknown, which is the research problem, is there's no study of the effect of humidity level on discharge cycle performance batteries. Okay, so because there is no study, there is a research gap. Because there is a research gap, yes, I can do research in this topic, in this area. Okay, if there is people already do a lot of research already on effect of humidity, then there is no research gap. And when there is no research gap, then there's no point doing research. Okay, so this one, the second topic, autonomous visual navigation. The topic is quite big, but specifically, what he is looking for is he looked at most of previous studies rely heavily on simulated environments, have limited validation in real indoor environment, and lack experiment to demonstrate real-world effectiveness. Also, there is a lack of research relating to combining indoor autonomous navigation and 3D map building. So you see how they have identified their research gap. And this is something that you must also do. What is your research gap? It's the unknown that you're looking for in your research. What is it that other people have not studied? Okay. This guy, propeller turbine design. The brief literature review survey shows that no one has discussed developing multi-objective optimization program for robust optimization and so on. Okay, which because of that, I want to do this. That's my research problem. That's the research gap. I've identified this research gap. So this research gap equals my research problem. If I solve the research problem, I can contribute something to knowledge. And that's research. If you don't contribute something new to knowledge, then it's not research. Okay? Anybody wants to comment on this? Right. Or ask question? Yeah, Hanif?
Hanif here. Can you hear me?
Yes, we can hear you better now.
Okay, thank you. Just a question, because just now you said if there is there's not a something new, then it cannot be considered as research. But let's say because sometimes we have a limited limited capacity to search or to know there's actually a research about what we think that there's no research yet, but actually there's already a research. Then how it will be considered? Is it still considered as a research or?
With the present technology that we have, internet databases and so on, there is no excuse for not knowing a research that somebody has already done. And if somebody did research but have not published, that means there's no published data, there's no published research about this. That's what you're saying. Okay. If they're doing research, that's different. But if they have told us that we are doing research in this area, then you cannot say there is no research.
I see.
Okay, so
Okay.
yeah, nowadays previously maybe it's difficult because everything is hard copy. You don't know whether the Chinese are doing something over the Japanese or the American or and so on. We don't know. But nowadays, I think there's no excuse. We should know. We should know even this year, 2024, who's doing research in this field, right? So there's no problem. We have all the search engines, all the databases, and so on that records every single research publication, thesis, and also journal, conference papers, and so on.
Okay, understood.
Okay.
Thank you, Prof.
Yeah. Any more?
Prof. Mio here.
Yeah, Neil.
Prof, should there is any new design or model has been developed and there's necessity for new analysis, I mean the necessity on analysis, should the analysis can be act as a research gap for the new design or model?
It depends. At field level, you can even replicate other people, other field, other fields, method or technique to a new field. For example, people in the aircraft industry are using a certain way of doing things and so on. You're trying to see whether that method can also be used in maybe in shipbuilding industry. Yeah. So you're trying to replicate or trying to introduce something from outside to a new field, new application, new way of doing things, so on. That is okay at MPhil level. But at PhD level, no. You have to be a bit more original in terms of your study. You need to come up with something new, maybe a combination of aircraft industry plus transport industry and so on. And then later you come up with your new things at PhD level. But at MPhil level, it's still okay.
Understood, Prof. Thank you.
Yeah. Somebody else has raised their hand. I forgot. Okay. Earlier, somebody, Shuang. Oh, somebody. Shuang, okay.
Oh, yeah, yes. I think the problem you are talking about is more about the environment in which the product is located. Then which may involve concepts in physical fields, community and air fields. That's what I want to say.
I don't quite understand, Shuang. What do you mean? What I'm talking about is about environment. What, can you repeat that?
For example, for example, you said the and the charge cycle performance of battery. No study of the effects of humidity level on the discharge and the charge cycle performance of battery.
So
The problem with much more environment with the wet eye. So I say you may build model to build the environment of the product using.
no, we are not talking environment as such, like the last one, we're not talking about anything about environment. We're talking about previous research. We survey previous research, see whether there are already research in this area that you are going to study. If there are already a lot of study on this, then you are not creating something new, no new knowledge being developed. But maybe certain specific area, still somebody have not studied or very little. Maybe somebody studied already, but not enough. That is your research gap. That is your research problem. Amirul?
Can you hear me, Prof?
Yep.
Can you elaborate more on the what acceptable research gap you mentioned just now for PhD level? Because like you say, for example, like replicate or analysis is not on par on that level. So can you elaborate more what kind of gap that is acceptable on PhD level? Is it only on novelty only that is acceptable or what? Thank you.
So like these are examples of PhD proposals. No study in effect humidity. Okay, they have limited validation. The second one, nobody has done on this and so on. Lack of experiment, lack limited validation and so on. And no, the last one, no one has discussed developing multi-objective optimization program or robust optimization in the sense of a propeller turbine design. So that these are very clear that these are specific field that has not been studied before, and I'm going to develop something new based on that.
Got it. Thank you.
Jana. Apa tadi Nurjana
Hello, Doctor. Hey,
Yeah.
Prof. Can you hear me?
Yep.
Yes.
Okay.
Prof,
What do you want to say?
what if there is a same research but a different method? What about that? Is
Like
that
what?
considered as research gap?
Yeah, I said this now. If it's MPhil level, that is enough. You basically use different type, different techniques, different method, and so on, or you apply a method from other place in your new application. Maybe somebody has never done this in Malaysia, but they have done that in Italy. Whether those Italian thing can be used here and so on, that can become a research gap. Nobody has done it in Malaysia, for example. That MPhil level. But PhD, no, I don't think. It's just application of other people's method in the new setting is not good enough for PhD. Okay? But we'll talk about this later when we go more in our second module, which is problem formulation. Now just give some example only, for you to appreciate from the beginning that research is always about new knowledge, which is already in your definition. So we are trying to hammer in your head that research, new knowledge, research, new knowledge, research problems. The problem when we say research problem is about research gap. Right. So you understand that first. Later, how to develop it, how to do it, and so on. We will do that in our second module, which is this next week. Okay. All right. Can we start? Can we go on? So here we're just trying to understand about basic thing that what are the basic characteristics of research, right? Okay, Hisham.
Side talk, doctor. I just want to talk about the. I want to ask about the review papers. You just mentioned about the research gap. So is it difficult to organize a review paper by one person?
Why a review paper cannot be done by one person?
I mean, because maybe it's difficult. I'm not sure.
No.
It should.
Everybody is supposed to do a literature review in their thesis. All right, that's it. That's the review, and that's good enough. If you do a proper literature review for your research, for your study, for your thesis, and that's basically what can be, changed into something into a paper.
Got it.
Later we have a module on literature review, and we'll talk more about literature review.
Okay, doctor. Thank you.
Okay, we go on. Okay, what research is not? So just something that, so that again you are aware that research has a particular, very specific thing that we are looking for inside research. Research is not information gathering. Gathering information from resources such as books, magazines, is not research. Journalists, scriptwriters will do this and they call it research, which is a colloquial term, which is basically like a normal daily work. After, oh, I've done a lot of research to write this script. Okay, that research is normal usage, not academic research. Not academic research. It's just research as a normal term. I've researched when I want to be an actor to hold the character of a person, for example, in a movie, then I do my own research to understand. For example, I have to be a policeman, okay, a police officer in the movie, or then I'll do my own research to study how policemen behave, okay, read about things about police and so on. So that's research. That kind of research is not what we mean here. What we mean here. What we mean here is academic research. When we say academic research, there must be generation and contribution to knowledge. If there is no generation and contribution to knowledge, then it's not research, even if you have gathered a lot of information. Okay, so just for you to go and collect information about uh, about other people and so on, that's not research yet. And the research is not transportation effects. So transportation effects mean you digitize hard copies, you plot graphs from tabulated data, you get data from a Department of Statistics and plot a lot of data and so on. And finally, you say, this is my research. You produce a lot of graphs, but that graph is just something, Excel graph that you can contribute. Say, but it's just you're just presenting the same data in the different format that does not make any contribution to knowledge. And design itself is not research. If your title, even if your title has something design inside there, developing design based on certain design requirement is not research. That means design of a turbine, design of a ship, design of an aircraft, design of a drone, right? That's not research, because designers are doing things like that already in the industry. They're doing that. They're not doing research because it's not really developing new knowledge as such. Okay, that's very straightforward. But design can be part of your uh, research. So that's why on their own, these do not qualify as research, but they could be part of the whole research process. So part of your research process is to design the turbine. But designing the turbine itself is not your research. This is only a part of your research process. In the methodology, you have designed the turbine. Okay, or you are coming out with a new way of designing things. That is research. But if it's just a simple, straightforward application of formula to design an aircraft or design a ship or design a car and so on, That's not research. But if you come up with new way, maybe you are using optimization methods, you're using genetic algorithm to improve the design procedure and so on. Yeah, that will be research. Okay, but if you just straightforward design calculation, calculate the size, calculate the dimension, see how much its strength and how much it costs finally and so on. That's just simple, straightforward design process is done by designers, not researchers. But researchers try to develop something new, okay, which is new, so that new will be the new knowledge. Okay, anybody have any questions or comments on this? No? Bharatan?
So if let's say design is like a person's contributing to the optimization of design or specific shape like that, so it's kind of research because they are doing the literature review and then they are giving their conclusion, their ideas like that. Is that so?
Yeah, yes. If it has something to do, like you go and do study. So design study, for example, design study. So you do a lot of design study, comparison here and there and so on. And based on that comparison, finally you can come up with certain conclusion to get proper, the way to get the dimensions of that object that you're designing and so on. Okay, that could be research. But again, we see again, is it just simple thing like that? Or is it you're trying to come up with something completely new, which become the level between PhD, MPhil, and finally maybe bachelor. Bachelor one, very simple. Okay, when you go to MPhil or master's level, a bit more complicated. When you go to PhD, we expect a bit more complicated and comprehensive in terms of the study.
Oh, okay. So just not the like a basic car design or basic like they're giving the industry just like designing a multi-structural platform like that. So that's not design,
Mm-hmm.
but
No, yeah.
contributing to the like providing a new shape like that is considered design. I mean research. Okay.
Yeah, yeah. So
Understood.
basically, maybe you could be developing something new in terms of new technique of doing things,
Okay.
techniques of calculation, or solving a certain part of the design process. Part of the design process, people have problem in this area. Maybe when it comes to the estimation of strength of the object, when they come up with something new. For example, if my student was looking at the new design of trimaran. Trimaran will be ships, yeah? Ships, if it is single ship, we call monohull. When you have the two hull, then we call it catamaran. You have seen that catamaran. But there are ships that are called trimaran. Okay, trimaran. The estimation of the um, the strength of the ship hull for the trimaran is a bit more complicated than catamaran and compared to even monohull. So my student is contributing towards that estimation, how to estimate that strength in a better way of doing the strength estimation. So improving the equations being used for estimating the strength. So that's contributing to design. Okay,
Okay.
how people design the catamaran, but because the trimaran is something new, and people still do not know a better way of doing the strength estimation for the side halves. Then because of that, there's the big contribution there.
Okay, bro.
Okay,
Okay, bro.
right. Anybody else? Okay, Dong.
Hi, Papa.
Sorry, teacher. I think design is a form of research because it requires the designer to have a solid theoretical foundation and uh, practical experience in this is the design process. Some new theory can be created.
Mm-hmm. Yeah, you can come up with a new theory of doing things that I mentioned just now. They have new formula for calculating strength and stress at the certain locations in the design. Yes. So to get to that, a lot of study being done, including experiments, not CFD, computer simulations and so on, finally to come up to a formula, a simple formula to estimate the strength. So you come up with new theory of doing it. Yes, that's research.
Thank you, teacher.
Okay, we go on. All right. So we see that research is systematic in the sense that we follow certain steps along the way. That is, you cannot start one before the previous one complete. Okay, or you cannot you cannot jump to step number 4. Yeah, so you must start step number 1. Step number 1 is always review of available literature, because you want to know what is the research gap, what other people have not done. That's why you must always start with available review of available literature. And then from there you formulate a problem. Formulate a problem means you identify the research problem, which is your research gap. So that's a formulation, problem formulation, which we are going to do from next week. We want to do about problem formulation. And then we select an appropriate research design. We want to go towards what? How do solve that problem? Are we going to do experiment, or want to use CFD, or want to use other numerical methods, or you want to use field survey and maybe full-scale experiment and so on, where from there we can collect the relevant data, we analyze and interpret the findings, we publish the findings, and that finding will contribute towards the literature. So by the end of our study, we have already contributed. That means the next person who comes after us, they cannot say that there is a research gap, and that research gap is we already found. Maybe 3 years ago we found that research gap. Okay, and we have already published. After 3 years we published this. So when somebody come in the 3rd year and say about the same research gap, they cannot say, because you have already plugged the hole. Okay, the research gap, you have plugged the gap. So that gap now has been plugged by you. So nobody else can claim that there is a research gap. So that's how we contribute to the body of knowledge belonging to mankind. Mankind have known this, and so on. So a certain part is not known. You found out that this is the part that you are going to contribute. You study and you contribute. You contribute by publish your findings. If you do not publish your findings, that means you did not write even a thesis or a paper, journal paper or conference paper. That means you have not contributed anything, because contribution means you publish. Okay, so that's why research must end with publication, with publishing, with writing, communication. Okay, so this is very simple, straightforward steps in research, but it must be in the same order. You cannot start, for example, you cannot collect relevant data until you have formulated the problem. And you cannot formulate problem until you have reviewed the available literature. And you cannot publish finding if you don't have anything before this. Yeah, so that's why it is called, that's why it is systematic. Yeah? And all research must have this. There is no research that you can skip any one of this. You must have. So in your research, you must identify where are you now. Okay. So one of the things that can happen is that some of lucky people who are lucky, they are studying under a research grant, so they become research grant student. Yeah, so they receive grant from the project leader, which most probably be your supervisor, And the supervisor says, come and just join this group. And maybe at that time they're already doing experiment, which is collecting the relevant data. So you have jumped the gun. You have not followed the systematic research process. You must remember that even if you are helping collecting the relevant data, you must make sure that for your research, for your project, for your thesis, you must start from review of available literature. You cannot run from here. While you are collecting this, you must check this and go to here and go to here, and finally, you make sure that your relevant data that you're collecting is really relevant to your problem. Because there's sometimes the data that you're collecting is solving. That means contributing to the project, the research grant, but not really contributing to your research problem, which is your own research problem. So you have to be aware about that. Any questions or comments on this systematic research process? No? Okay. So it is important to make sure that your research is systematic. Now we go to systematic scientific, yeah? Scientific. So it must be systematic, it must be scientific. So systematic means it follows the step-by-step systematic, like what I've shown just now. And like this, for example, problem identification, review literature to understand the nature of the problem to be studied, identifying the specific gap in knowledge, hence the research problem, set objective to solve research problem. So this is problem identification and problem formulation. The subject of our next week's class, we are going to do with this, yeah. And then we review the information, further review to understand how others approach the depth problem, select approaches. Okay, so this one is literature review to find out how people have done it. This is what people have not done. Here, whatever that people have done, close although they have not done all, but the previous studies that people have been doing, what methods did they use? How did they approach? What theory did they use, and so on. And now you have to develop the methodology, which consists of a series of steps to achieve the research objectives. You do data collection in an organized and controlled manner so as to arrive at valid decisions, analyze and interpret the data, and a conclusion and communicate. So you must follow these steps like this, yeah. And you cannot overstep one, or you cannot start at number 3. You must follow these steps. Any comments, questions?
No, it's okay, bro.
Okay. Right. Now we go to scientific. Okay, many times scientific appears in our definition. You see all the definition previous class has scientific, but we need to know a bit more about scientific. So the scientific method is a body of techniques for investigating phenomena, acquiring new knowledge, correcting, integrating previous knowledge. Okay. To be termed scientific, a method commonly based on empirical measurable evidence, subject to specific principle of reasoning. Oxford generously defined the scientific method as a method of procedure that has characterized natural science since 1723, consists of systematic observation, measurement, experiment, and formulation, testing, verification, hypothesis. So, in our next part of this class, we're going to deal more about scientific method. I have a complete slide on it. When a research is using scientific method, any conclusion, theory, finding must be based on empirical evidence, observed, measured data, and proven facts. And the evidence must be reliable and valid. Very, very important. Yeah? So you must remember, when it is scientific, okay, when your research is using scientific method, it must be based on evidence, observed, measured data, and proven facts. And the evidence must be reliable and valid. So when we say evidence here, it must be reliable and valid. So what we mean is that if whatever that you do, you must ensure that you have arguments, you have evidence, you have reasons for doing it. And those claims that you say that this is how I do it, or this is what I got so far, this is the data that I've got, and so on, you must make sure that they are reliable and valid. Okay, so reliable means it is something that you can rely upon. It's not something like conjecture and so on. Yeah, and it is valid. It is really actually showing the exact value that's supposed to be there. Yeah, when we say, for example, a thermometer, okay, is showing valid readings. That means that if you put in hot boiling water, the thermometer is showing 100. If it is not showing 100, that means the reading from the thermometer is not valid. Okay. Reliable means the thermometer is always showing 100. Anytime, every time when it is hot, it's showing 100. When it is boiling, it is showing 100. But we don't want something like at this time it shows 100, some other time 110, some of the time it's 90 and so on. So that's not reliable. Okay, it's not able to be repeatable, reliable, repeatable. Okay, so what we cannot base our findings. Hearsay, that means that yeah, something we just heard. Feeling, I feel. Emotion, again, that's the feeling. Wahyu or inspiration, because we are not prophets, so we cannot say that the value is 200. You say how? Well, I dreamed last night that it is 200. Okay, or somebody told me I got an inspiration that it is 200. Okay, in dreams cannot. Okay, other people's unvalidated opinion. Okay, even if it is your supervisor. So I need to put a certain note here. Please do not say my supervisor says this. It is wrong. It is still, that is not reliable and valid argument. Okay, because some people, some students, during mini Viva, I think in Viva, I think they learn already notes. They say, I'm going to choose this one because my supervisor says that it is the best. Okay. According to my supervisor, okay, we need to use 100. So you cannot use that. Even if your professor is a big Nobel Prize professor, okay, you cannot say your supervisor. You cannot say even your name, the name of your supervisor. Okay, Professor Ali says so. But you can only later we can say we will later we have some slides in the when we deal with problem formulation. We says what we mean by reliable information. Okay, reliable sources. Okay, your supervisor is actually not a supervisor, not a reliable source that you can defend, that can defend you. You cannot say, oh, my supervisor is the one who did it. No, even if your supervisor is so much very celebrated professor, you cannot say that. Okay, even if the people examining you, evaluating you in the mini viva are just junior lecturers, no, you cannot say your supervisor says so, and you expect people to accept that. Okay, that's not scientific, because any people who is not but if your supervisor, say your supervisor name is Ali, but if you say that Ali 2022 says, according to Ali 2022, then Ali 2022 is not your supervisor. Ali is your supervisor, okay, Professor Ali. But when he writes a paper, that paper is referred as Ali 2022, it refers to that paper published in 2022. That paper says so, then it's okay. So I hope you understand the difference. Your supervisor as a person and your supervisor who has written that paper written by your supervisor that has been published in a respectable journal, okay, then then it is accepted, yeah. Otherwise, no. So that's why an unvalidated opinion means anybody's opinion which is not validated. But if your supervisor's opinion has been validated in a paper, in the journal paper, then okay. But if your supervisor opinion not validated, just his own opinion spoken to you, then cannot. Selected testimony. I hope you know what I mean here. That people selling supplements, okay, traditional medicine and so on, always they put testimony. Mr. A says that his grandfather already cured from gout because of taking this thing, and Mr. B will say that, yeah, my mother also already, everything. You have all the testimonies from perfectly customers who are very happy with the services and so on. So those testimonies are not acceptable from scientific point of view. They are not scientific. So always, yeah, when you see these people selling things using testimony, please note, if since you are doing research methodology, you are a researcher and so on, you know what scientific means, then they're not scientific. Yeah? Selected testimony are not scientific evidence. And pseudosciences, I'm not sure whether you're aware also. This thing which look like sciences, but they're not science. Okay, the so-called. If you see in YouTube, there are so many claims. People can say many things. They say they can probably produce energy from nothing, and so on. All these are many pseudosciences, not based on real physics and chemistry and biology and so on, but they claim to be doing many things and so on. So all those we cannot use. So make sure that in your research, you refer only to valid and reliable evidence. One of the valid source that you can use will be evidence from writings. That means from publications. But you must remember that publications also some publications are not reliable and not valid. So we must be aware of such thing. Yeah. Okay. Anybody wants to comment on this or question?
Yes, Prof. Can I say something? Chen here.
Chen, yes.
Hi, Prof. So is that mean when we doing our conclusion for our thesis or our papers, is any point that we're going to we draw any conclusion that we draw, we also need to refer to publications?
Yeah, no, what we mean is that the conclusion itself is okay. Well, your conclusion is based on that conclusion is whatever that the findings basically. When you write the conclusion, there's no need to refer to publication at that conclusion end. But that conclusion is basically you have concluded already what has been written before this. That conclusion, what you mean conclusion of research, okay, not conclusion of papers.
Okay.
Conclusion of research. How you conclude? You say that, yeah, this thing is good. How do you conclude that? You must have reliable and valid evidence. You cannot base on, yeah, I think it is already good. That's you feel. You feel. I feel that it's already good. I feel I have achieved my objective. I feel that this thing is better than this thing. How do you feel? How do you mean? What do you mean? How do you feel? Why based on your feeling like that you say that this is better than that? No, you must have evidence. The evidence, this one is 100, this one is 70, so this one is better than this, like that. Must be hard evidence, yeah.
Okay, so it has to be based on examples, our experimental result.
Yeah.
Then
Mm.
our experiment result can be correlated to other publication or other people work.
Yeah. Mm-hmm.
Thank you.
So evidence is data or other people's data also can, or other people's publications also can. So all these evidence are varies, depending on what research we are doing. So as we said, we are dealing with research not only in science and technology, even in history and so on. They cannot be based, even in the religious studies. They cannot say that I have got wahyu. That's why I write my thesis like this. Yeah, I got inspiration, right? So no, they still have to have reliable and valid evidence. So for Muslim, for example, when they want to write something, they say this is what the Prophet says. Prophet Muhammad says this. They cannot just say that. They must say where did Prophet Muhammad say that and where is it recorded. So that's why the people from all the time, they have already made sure that the hadith, which is the sayings of the prophets, has been uh, checked and by the previous scholars, and they have produced into the six books of hadith. If the hadiths are inside there, then that's considered as valid and reliable hadith, saying of the prophet. But if you write something, you do not say that this is from any of the six books, then that means that anybody can say anything, that the prophet said something. So that's not reliable. Yeah, that's not valid. Okay, Hisham.
Doctor, beside the wahyu and the feelings, the visual inspection would be valid.
What do you mean by visual inspection?
Uh, for example, if we create a device that releases the stress in children, so the therapist could visually see, okay, this kid now it's not in stress. So it's visual inspections.
It is not, unless it is validated somewhere, because kids can do anything, you know. So still you need to have some kind of validation that, yeah, that's how kids behave when they feel good. So you need to have some validation. So
Okay.
yeah, in certain aspect, of course, you need to do some measurement. If it is really this, what we talk about here will be more of about you being really you about feelings, yeah. So, but if other people feeling, you can measure that. That's okay. But you cannot say because of my. I feel this is the correct way of doing it. I
Okay.
feel I need to choose this method. No. So that's what we mean.
Okay, that's
Okay. So remember that when we do research, it must be systematic and it must be scientific. Okay. Now we go on.
Prof,
Okay. Yep.
just want to ask Amirul here. In regards of reliability and validation, what are your thoughts on the article or journal that is older than 5 years or maybe longer?
Okay. We will deal about sources here later in our next 3 classes or something like that. The next second, third, maybe another third or third class from now in detail. Okay. But for now, the simple answer is as much as possible, make sure that your research is current. Your literature is current. Okay. Imagine if you do your research gap just now. Okay, you say that, oh, based on the literature that I've seen, there's no one who have done uh, a study on this particular aspect. But your conclusion is based on 5 years ago literature. But maybe yesterday or 2 months ago, somebody has already published already something exactly like what you want to do. So it is for sure you need to make sure that your literature is current. as much as possible. It should be yesterday. I told my student it's yesterday, not even 2 years ago. It's yesterday. You must see whether somebody has published something about before you conclude that there is no literature in this particular area. Okay.
I see. Meaning in terms of reliability, is not that reliable, right?
No, it's not. It's not reliable. Reliable is reliable. When you say later, we see the quality of journal article and so on. Later, we are going to deal with that. But if it is in general is reliable, okay, but it's published 5 years ago, it is still reliable evidence. But what we mean is you cannot say that just based on those 5 years ago reliable evidence, you conclude that there is no work in this field. Okay, so it's not the wrong thing. It's not the evidence. The evidence is already reliable, but your conclusion is wrong because you did not refer to yesterday's. You did not see yesterday's publication. So it doesn't. All literature does not degrade its quality. If it is already quality evidence, it's good evidence, but it's just not current. Okay, sometimes you need the old literature. Okay, maybe certain equations and so on are published in old literature that people do not update, which is okay to be used. Bernoulli's equation has been used for maybe, I don't know, whether 100 years, but many years. It's still valid. Okay, so there's no problem about using old evidence. But for what purpose? If the purpose is to find research gap, then you cannot use old article.
Got it. Thanks.
Okay. Right. Evidence. One important aspect of scientific research is the verification of evidence. We need to verify the evidence, argument, fact that we use to support our argument. So remember this one. Everything we write in our thesis, our papers, our presentation are subject to scrutiny, to a question, to the need for provision evidence or supporting fact. So when you write your thesis, when you write your proposal, when you write your paper, when you make your presentation, every single word, okay, every single word, or you have a figure there, ask why you put this figure here, where you get the figure from, what does this figure say? So if you do not want people to ask about that figure, don't put it there. Always remember that. And evidence could either be from one, scholarly accepted literature, or your own research, your own experimentation, your own survey. These are the only two that you can use in your as evidence in your thesis. Okay. For example, you may say that this equation, I'm going to use this equation in my research to analyze the data that has been collected. People can ask you, why you use this equation? Why not the other equation? Well, people, you can say that according to David 2009, this equation is the best in this particular application. Okay. Right? So you have evidence from scholarly accepted literature. Or you do your own research. You did a number of experiments to check that this equation is the best. You check, you put the data into the equation, and you get the results. And then you do experiment, you get the same results. That equation has been validated through my own experimentation. So you validate your, you use the validity of your argument, your evidence is either you use scholarly accepted literature or you use your own research, experimentation, survey, and so on. But people will question whether your experimentation was done correctly and so on. I've done my experimentation correctly. I have calibrated all the equipment. Okay, I recorded the data properly and so on. So is that I got these results. Okay, so these are the only two accepted literature. Otherwise, no, you cannot say that I think this is the right equation to use. Or my supervisor says this is the right equation to use. And then they will say that, for example, you are going to use a drop test. Okay, maybe a certain thing they need to do a drop test. Okay, drop test should be done from 3 meters. Why you use 3 meters? That's the I just feel I like to do 3 meters. Okay, so you cannot do that. You must have an argument. Why you use 3 meters, not 4 meters or 2 meters or whatever? Because so you see, from literature, Mr. A, Mr. B, Mr. C, Mr. D, all use 3 meters. Or there is a standard from International Institute for which says that for this kind of test, we must use 3 meters. Okay. So why you use that 3 meters will be questioned. And you must be prepared to answer, give evidence. Why? Okay, so if you have the International Institute set it to be 3 meters, okay, then become 3 meters. Then it is acceptable. So we cannot just base on whatever that we choose there, only on we feel we just want to take any arbitrary value. We must use the argument. The argument must be either scholarly accepted literature. I mean literature which is valid literature. And as I said, we are going to deal with that later, or our own research.